Hello everyone, welcome to another episode of our Farming RPG tutorial series. Before we get on with what we want to do today, some things we need to fix. Right now, if our player uses a watering can, he's able to directly change the soil to watered. But by right, the player should only be able to change the land state to watered if we first till the land with our hoe. And also, when we plant our seeds, you don't see them popping out. It's because they are buried within the ground. See over here. So let's fix it now. So let's go to the interact function in the land class. Let's move this, set its initial transform position of our crop object to 0.1. So it goes up a little bit. And also let's an if statement under our watering can. So it should only be watered if the land is tilled. To do that, we just make sure that the land status is not the soil. With that, we can see that I can't water unless I first till it. And now you can see the seeds that we plant. So all is good. But once I leave the scene and come back to my farm, everything is reset. And that's what we want to do today. Oh, and also you have to tweak the returning point a little bit. So let's set this to 0 and this set to 1. I did not position this correctly in the previous tutorial, but it's fixed now. Okay, so let's get started. So in order to make the state of our farm persistent, we need to keep track of it. So let's make a class called Land Manager to keep track of the state changes around the grass. So after we create the class, drag it into farming area. We'll make this a singleton first. Next, let's have a list of land plots. And we'll create a function to register it. Since we put it in the farming area, we just need to get all the children here. And assuming all the children are land objects, we just do a for each. All this register land plots. And then we'll add this to our land plots list. Don't forget to call this in start. Everything's in order as well. Now we also need our land to keep track of its own ID. So in future, if you want to make a reference to it, we can just submit its ID. Let's declare this public int ID. And then we can just set. So we just set the land ID to land plots count is 1. So for example, if this is the first land object, land instance being added, it would be 1 minus 1, which is 0. So it would be 0 in the array. Likewise, if it's the second, you'll get the ID of 1 and so on. So now that we have that, we need to represent our land instance in a serializable format. Because once we leave the scene, we won't be working directly with any land instance anymore because all of this will be destroyed. So we need to create a serializable format so that in future when we want to create a save system, we can easily write that data to a disk. So let's create a folder and save. And we'll do this for the land first. Let's create a new class. We'll call this land save state. Open it up. It's going to be a struct. And what it's going to take in is basically the information that we want to keep. So what is the information that we need to keep? It's basically the land status and the last time it was watered. Everything else can be generated based on these two fields. And then we just have to create a constructor. And there we go. We also need to create one for the crops as well, because we want to save the state of each plot of land and the crops planted on it. So create a new script, crop save state. Same thing, make it a struct. This is serializable. Likewise for land save state as well. Now what do we need for the crop save state? So when we want to save the crop, we need to know where it comes from. And so the first thing that we need to save is the land. And next, let's take a look at crop behavior. We definitely need to know the seed it will grow into. All these things we don't really need to know because this will be calculated from this. But we do need to know the current growth of the crop and the current stage of growth it is in. You need to know the health, whether it's close to wilting or not. And yeah, I think that's about it. Let's do this. Now we are taking this as a string instead of a scriptable object directly, just so in future when we want to write to disk, we'll be able to save it in an easier reference. And finally, let's make the constructor and see the crop state, growth, and health. Now that we have our land save states and crop save states, let's go to land manager. We'll declare these two things. Now, let's go over to register land plots. For every new plot of land we register, create its counterpart in its serializable format. And data. So now that it's registered, we'll figure out how to update it. So whenever there's any change to our land instance, it will need to inform land manager of its change. So let's create a new function. We'll need its ID and everything in here. Update it, it's just taking its ID with the land status and the last time it was watered. Now that we have this updated, we just have to call this function every time there is a change to this instance. And luckily, every change to our land's instance happens in one function, which is switch land status. As mentioned before, land save state records the land status and the last time it was watered. And this function does both. When it changes the last time it was watered, it's also handled in this function. When it changes its status, it's also handled in this function. So all we need to do is go to land manager, front instance at the bottom. Oh, I forgot. Static. Make sure the singleton instance is static. And then we on the land state change it. And then start it with D, land status, and time water. Now if we were to test it out, 432 land plots, 432 land data as well. Now let's see what happens whenever we surround. Yep, it corresponds accordingly. This was element 5 and it's farmland, so we know it's working basically. Next, we just have to handle the loading and the saving of the data. So to save, we'll use a static variable, because static variables operate independent of its instance. So that means that even when land manager doesn't exist in the scene, you're able to still access it. What we need to save is the land save state and the crop save state. So to make things easier, we just store it in one static variable called farm data. And we store it in the form of a tuple, which is a versatile, lightweight data container that lets us store multiple data elements. In this case, it's using the tuple under the system namespace. Because what I like about this namespace is that it can be nullable. So by default, we're going to set this to null. We're going to take in list of the land save state, and type 2 will be its list of the crop save state, and it will be null on default. That way you don't have to set up a class of our own just to make it nullable. You can just use system tuple. Why this is important is, after we register the land plots, in start we can just check if farm data is null before we load any save data. So that's basically the purpose of using this system tuple. Right, so back to saving. So how do we save it? It'll be quite messy if we want to save whatever changes that is made here immediately to our farm data whenever the land state changes. Because this function is called from the start, from the very point we register our land plots. So we'll only save whatever changes were made here over to our static farm data when the player leaves the scene, because that makes sense, right? These variables are when our player is in the farm, and this to be written over here when our player is somewhere else. And then when our player comes back, we'll take this and put it back here. Okay, so we could always do it from Scene Transition Manager, and then we can just write it down, or the if statements. If this is in the farm, then we do this, and if not, we do that. But that's quite a bit of work. We don't need to do that, because what we can do instead is on destroy. Because you see, when the player leaves the scene, that manager will be destroyed. It won't be around anymore. And that is when we can do the saving. So let's do just that. Farm data, new tuple list. And just like that, we have found a way to save our land and crop data. Now is to handle the loading. So to load up our land data, we first need to create a function that will take in whatever's in our serializable format and convert and implement it in the C. So how we're going to do that is to create a new function. Load land data. We'll take in status to switch. Easy, right? But we also need to switch it in scene as well. So we'll need to take this, put it here. Because we're basically doing the same thing as switch land status. Yep, but the difference is we're not going to record the last time it was watered. So yeah, it's just to render it. And with that, now that we have the loading function set up, we just need to have a function to import this land data. So let's create a function. Basically, to import, it's just to load it from the static onto our instance. And with that, we will need to do a for loop. Oh, first we need to take in a list of, let's say, states. And data set to load. Right, so for int I is 0, I will set to load count. So the individual land data to load is land data set to load. Right, so we get the individual land save state first. Then we take that and load land data. Let's do the same for our crops. Oh, don't forget, our land data must be set to the data set. And for now, we'll just crop data to the crop data set. So now in start, when we want to load our farm data, let's call our import functions. This will be farm data dot item 1. You see, land save state, then crop save state. So this is item 1. And the next argument is item 2. Now let's test it out. We get a bunch of errors. This is probably because we have not loaded the farm data before our land instance has called its own start function. And our land instance's start function, it's where it gets its renderer and basically sets up the selects and everything like that. So we need to delay the calling of this until everything is done on their end. So let's make an coroutine and we'll call this load farm data. And we'll wait until this finishes. We need to wait for end of frame. So this basically waits until the first frame finishes loading. Then we load the farm data. This end, we start the coroutine, load farm data. You need to register the land plots before the land does its first update. So actually, we'll use on enables. Let's try this. Yep, and so we basically have each of our land reserved, which is what we want. So now, let's load up the crop data. So first, we need to save our crop data on every update as well. We do this. Same thing as our land state changes, but for the crops. And the first thing it's going to take is the land ID, because that's the identifier that we're having. Everything in here, except this is going to be seed data. And then we also need its register function as well. We'll be using the observer listener pattern for this. So we'll need a function called register crop, which will take in everything in here as well. So everything here. Now this is different from our land plots because the crops can be harvested and destroyed. So we also need a deregister function. So deregister crop. And just need a land ID, because the land ID is its identifier. So to find it, we first need to get its crop index. This is with crop data.find index. No, actually, instead of finding, we just need to remove it from its index using remove all. So to remove all, we just have to find a matching land ID and just remove it. But on its update, we'll be using the index. Find index. And then to update, we just need to convert the seed data into the string. Actually, we don't need this, because once we find the crop index, we can just get the seed to grow, accessing our crop data. So that way it doesn't have to keep passing the same seed data again and again and again. Then afterwards, then we just take everything in. Yep, so we have its updates. Let's organize our code a little bit. So these are the state changes. These are for registering the crops and then okay, everything's much neater now. Let's move on to our crop. So the first thing we need to do is register it. So in crop behavior, under plant, we will need to register. We'll take in our land ID, grow, crop state, growth. Where do we get our land ID from? So we change the parameter of our plant function to include the land ID. And now over in our land script, when the player is planting the plant, its ID, there. Now we also want to load up the crop from Land Manager. It's going to instruct the crop to instantiate and then load it onto the land. And a lot of what we want to do is already on the plant function, except that we don't want to re-register the crop. So let's create a separate function. It will take in everything here. And we'll also need a new variable. So in the future, when we want to update the land manager, we have a land ID to pass it on to. Now we can't just have a string seed to grow, we need a seed that. Take this, put it on here. Seed, we'll change it to crop state. So the land ID is set, seed to grow is set. Crop state has to be set as well. Next is the growth and the health. So we just add the growth down here. Now back in plant, we just include crop, seed to grow, crop state. By default, it's going to be seed. Its growth is 0, health is 0. Because when you first plant it, you don't need any of these. The health will only start when it reaches its seedling stage, which is what we previously did. So yeah, now with that, let's see if we can crop data is recorded. So now when we plant a crop, it's recorded in the land ID, the seed that we're growing it into, its growth and health, which is good. And then if I plant some more, get tomato seeds as well. Now when I start to water them, nothing happens because we have not updated its growth yet. So now let's go crop behavior. Which places should we call the update function? Now, our crop will only change in its state when it grows or withers. See, its growth field is increased. The health is affected as well. The state is also controlled here. So we just have to put it at the end. And manager.instance.upstate change. Likewise in wither, so it's in growth and so now when I plant it, you see that its growth is controlled here. You can see the state of its health as well. And when we harvest it, it does not deregister because we have not called the deregister function yet. Don't forget, it's on destroy. So now when the crop is fully grown and we harvest it, it should be removed from the list. And when I remove it, it gets removed from the list. Yep, so it works. Now we just have to handle the loading of the data of the crop data. Now, when we want to import the crop data, we run into a problem. Because when we load the crop save state, it stores our seed to grow as a string. So we need a way to convert this string back into our scriptable object. So to do this, over in our inventory folder, let's create a new script. Call this item index, the scriptable object. What it's going to have is a list. And now over in our data folder, create a new item index for this item list. And we'll add every single one of our items here. So starting from our tools, seeds, other items. Yeah, that's about it. Then over in inventory manager, let's put our item list here. just have to start find. Now back to our land manager. We want to import our crop data. Just need to first convert, go for each loop first. You access the land, spawn the crop. So you need to do these three things. First, to access the land, it's pretty simple. And to plant would be our plants. Crop save land ID. Then over in our land script, how we spawn our crop. When the player plants a seed on the land, it basically instantiates it for us. Then we set its transform, and we access its behavior. We also want to do that over in Land Manager. So what we can do is we split this up into a separate function. We'll make it return a crop behavior. We're in a function called spawn crop. We're going to return the crop planted. Then over in Land Manager, spawn the crop, just following this function. And then since it returns the crop behavior, we have this. Now we can just use this crop to plant, load crop, and then we can use our crop save land ID, get in the seed to grow, use inventory manager, start index dot string. And then we have to cast it to seed to grow, save dot crop state, and so on. See it in action. Go out and come back. We've not imported anything. Land data is loaded, but the crop data is not. So the problem why it didn't work was because it was gonna deregister the crop every time we left the scene. So we can't put this on destroy. So what we should be deregistered right before it's destroyed here. Yeah, that's the only time it's destroyed anyway, I would see. There's no other place in crop behavior. Yep. And also when player destroys it with a shovel. Actually, let's make a function to do this. Now over in yeah, I think that's about it. Yep, everything is exactly as we want it to be. And that's it for this tutorial. I hope you enjoyed it, and we'll see you next time.